In this problem, our variable x is representing an estimate for the number of hours it would take to build a house. We're also told that x is over 2,000. Now the goal is for the actual man-hour count to be within 100 hours of the estimate. The other piece of information we have is that the y variable represents the actual number of man-hours it took to finish the construction. So our goal is to create an inequality that represents the relationship between the estimate and the actual man-hours so that the goal is correct, that y is actually within 100 hours of the estimate. So we could start off by saying that y, the actual number of hours it took to build the house, we want that to be less than x plus 100. Remember, x represents the estimated amount, and then if we were to add 100, that would be the maximum limit to fit within these constraints. But we also want the actual amount of time it takes to build the house to be greater than x minus 100, which would represent 100 hours less than the estimate. So you can see that we're kind of sandwiching y between those two limits, the lower limit and the upper limit. One thing we could do here, you might have an idea already that the answer is going to be D because it kind of fits this setup. But what we can do is actually subtract x from all three sections of this inequality, and those x's would cancel out, and then we would have negative 100 is less than y minus x, which is less than positive 100. So you can see that's how we get option D as our correct answer. All right, that's all for this video. Thanks for choosing JD's Prep.